So, it looks like the universe is all about water. Either you like water, i.e. you're hydrophilic, or you dislike water, meaning you are hydrophobic. Sure seems like water is really important. Let's see what Professor Michael Levitt thinks.
Hey, hi Johnny.
Oh, Mike. Wonderful to see you. I'm so glad you're here. Why don't you come in? Hi, Mike. It's great to have you here. I'm so happy you're here to talk with our students.
Well, it's really great for me to be here. Oh, I'm sorry.
Don't worry, it's only water.
Well, important stuff, water, you know. Besides the fact that we drink it and it keeps everything alive, at a molecular level, it is probably the simple molecule that's most like life. In other words, if you wanted to say what is the basic component of life, it's water.
That's fascinating. Why don't you, or can you elaborate?
Well, certainly. So, it's a liquid. It doesn't look that interesting. Mm-hmm. We obviously know we need it very much. And what's really important about water is that our cells are full of water. And the molecules that are in our cells, the proteins, the nucleic acids that carry out all the really important essential functions of life, can only do it because there's water. If you pack spheres together, they'd like to have like 12 neighbors. So water actually likes to only have 4 neighbors, and that's why water has really strange properties. So for example, ice floats on water. That's unusual, because once it becomes ice, it expands. So there's things like this that are very interesting, but proteins and DNA, for example, hydrogen bonds are essential. The whole genetic code that allows us to reproduce is hydrogen bonding of base pairs. Water also can hydrogen bond to those base pairs. So water can regulate the strength of a hydrogen bond. If DNA was in vacuum, it would never come apart.
I see.
So you couldn't actually reproduce DNA at all.
So in essence, the water is more than just being a solvent. It actually participates in biological reactions?
It participates in biological reactions, but water is going to be important at every level, because without the water, proteins wouldn't be stable, reactions couldn't happen, and so on. So it really is the essential solvent of life.
And if I look at a protein, it interacts with the water. Are there different kinds of water? Water that's organized around the protein and associated? Or is it all sort of floating around and going in all directions?
So the whole thing about different kinds of water. So water is an interesting area because people think water has all kinds of strange properties. And I think one analogy I would give is, so water molecules are moving around all the time. But the water molecules next to a protein are moving less. Now the reason they're moving less is if you had a dance room and everyone's trying to dance, people standing near the wall are moving less because they can't move into the wall. So you get a restriction on movement, not because of there's been a lot of discussion about how structured the water is, and it might form fleeting structure, but fleeting structure is not really structure. I mean, if something forms a structure for a millionth of a second, it's not exactly there. So I think that water essentially behaves as a lot of quite complicated objects. A water molecule is more than just a single sphere. It's like a little V with the H2O. So there's 2 hydrogens and an oxygen forming a little V. And that gives rise to all sorts of interesting properties of water. It really is a unique liquid. And it seems to me, I cannot imagine any life form that would evolve naturally without water.
You mentioned that water has some strange properties. So let me ask you, does water have memory?
I would be very, very surprised. I mean, in physics or chemical physics, you can measure memory, which is basically that if a water is doing something at a certain time, what is it doing? Does it still know what it was doing? So basically, if a water molecule is moving in a certain direction, and you look at it a millionth of a second later, it'll probably still be moving in that direction. But 10 millionths of a second later, it'll be doing something different. The reason is that the water molecules are constantly colliding. And because when things collide, they change direction. So I think it's extremely unlikely. I mean, when people talk about water memory, they talk about memory lasting hours or days. You give me water from a tequila flask. I didn't taste any tequila. Now, there may be one molecule of tequila in there, but that is not what people mean. They mean something which is really tangible and noticeable.
Let me fill you up again with a tequila flask, just to make sure that people realize that here at Tel Aviv University, we drink high-class water.
It makes me disappointed to think where it came from, but anyway, I wish it had memory.
Yes, that is true. Mike, thanks very, very much. That's fascinating, and I will definitely get in touch with you in a later lesson. I hope that's okay.
Thank you. I'm looking forward to that.